Welcome. We have understood what storage class is and what are the different types of storage class there are. According to our understanding with the storage class, there are two types of variables. One whose life is equal to the life of the function, that's the auto kind of variable, and another whose life is equal to the life of the program. Global and static kind of variables are having life equal to the program. Later on, we will know that there are other allocations whose life is again not dependent on the function's life. The memory that we acquire dynamically in runtime are not dependent on the function's life. They are going to be allocated as long as the programmer wants them to be allocated in the memory. So there are basically two types of allocation. One whose life is equal to the life of the function. When the function starts, they are allocated, and when the function ends, they are deallocated. And the other types of allocation whose life is not dependent on the function. So operating system creates two area in random access memory or primary memory. One is called the stack memory area, which is typically for the allocations whose life is dependent with the function. That means whose lives are equal with the life of function. And the other is the heap memory area, where the allocation takes place whose life is not dependent on the function. That means they are dependent either on the total program or programmer's wish. That means if there is a global allocation or static allocation or allocation using some dynamic memory allocation technique like malloc or calloc that we will understand later on, then they are allocated in the heap area of the memory. So operating system demarcates the RAM in two sections: stack for auto variables and heap for non-auto, global, static or dynamically allocated locations. That's the idea of heap and stack, and we can have a block diagram in order to understand this in a clear way. So let's have a rectangle here. Consider this as a RAM. So there can be a stack. There is a stack area where the locals are allocated, and the operating system maintains a top variable in order to mark up to which the stack is allocated. Now when we start main, so we have a variable x, so 4 bytes will be allocated from the top. So these 4 bytes are for x, and then we are going to the function fun a, and in fun a you can see that there are two variables p and q. So again 8 bytes will be allocated, first for p and then for q. So the top will be here when we are in function a and these two are allocated. Again we are going to function b, jumping to function b as you can see here in this example, and we have these two variables a and b. So again 4 bytes will be allocated for a and b, and the top is going to be actually there after b in order to mark up to which the allocation is. So the top will be taken here. Now when the function b is over, then the function then the control gets back to function a. Now when the function b is left, then this a and b will be deallocated. So what happens? The top will be taken back to the location here. That means these are now deallocated. So when the function is over, the top is taken back. Now when the function a is over, then again the top will be taken back. That means it will be actually put here. This is the top. Now here. Now when the main ends, again the top will be taken back to the initial location where it was prior to the starting of the program. So that's how the management of the stack takes place. So when the main is over, the top will be taken back at the initial location. So that's how the function call and the memory allocation takes place, auto memory allocation takes place. Now you can just logically think that we cannot have a variable in between of these allocations whose life is not dependent on function, because the top movement of the top will deallocate that particular variable as well. So the global variable or static variable or any other allocation that is not dependent on the function's lifetime should not be here within the stack. So they are actually kept in another section that is managed totally in a different way, that is called the heap area. So if you declare a static variable or global variable or a variable or a memory that is allocated using dynamic memory allocation technique, they are allocated somewhere that we call heap. So this is the idea of heap and stack. Thank you.